Hello guys, I'm Enzo and I'm back with the third video of MATLAB DSP Introduction. And today we're gonna take a look at the waves that we can generate in MATLAB, and they are useful in DSP signal processing. And you will always need to build a wave, or I don't know, made an oscillator, and also it helps us to figure out some of the theories that we learn in the books. Okay. uh, First of all, the most popular and most common wave that we're going to see in the DSP lessons is sinusoidal one. Okay. The function that we want to use in order to make a sinusoidal wave is sin. Okay, and we need to insert a number here, and it will return the value of this to the x. So we need to have a frequency, okay, and this frequency is multiplied by 2 pi, and it's we need to calculate this over the time, okay. And here we need to define frequency. What frequency do we need the sinusoidal? For example, 4 hertz. And time, we need to define the time between, for example, second 0 and the second 4. Okay, in order to make a simple calculation, and also to observe it in the plot, and also check if it's correct or not. Okay, we don't want to go from 0 to 4 by a step of 1. We want to go a little bit slower in sampling, so we need t, or the period, to sample the sequence from 0 to 4. Okay, so t is equal 1 over frequency sample. Okay, and then what is our frequency sample rate? It is any number you want. As it goes higher, our sinusoidal wave will be smoother. So I'm gonna pick 500. They usually go with 44.1 or 44.1. They usually call it, but 500 is enough in our case. Okay. So let's see what happens if we uh, plot this one. So let me make these things clear here. There's to avoid confusion. Okay, and as we need to plot a lot of things, I need to close all the previous windows, so every time it will pop up. Okay, here I need to plot the x, and also we can insert the time that we have, and also we can avoid it. Let's see what it's like when it's first F5 of your, or run of your script. It will take a while, but as it proceeds, it gets faster to run it. Okay, here's the window. You know, there are some kind of irregularity in the sinusoidal wave because of our sampling frequency. Okay, it doesn't matter now, but let's check something here. How many periods do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, we have 16 periods, and also it was in 4 seconds. So our uh, frequency is 4. Okay, that's something we wrote here. If we change it to 6, we see uh, 4 times 6, 24 periods. Okay, I'm sure it's 24. If you want to count it, there's no problem for that. Another thing you may like to see, it's smoother. Look up this shape. We can increase the frequency of 15. It's supposed to be 500. Sorry. Okay. Let's see. You see, it's got smoother, and that's it. I'm going to show you a way how to count all these things uh, really quick. So just to make sure, uh, x equal to 1. So x equal to 1. And let's see the results. I need to put it in O, for example. X equals to 1. And there's a problem with this. Oh, it's not 1. So I'm gonna put this number so we get better results. We can put 9999. It's a little bit, cruel that these things equal greater or greater or equal to 995. It's may not gonna work because so maybe we should increase the frequency. 44, great. Okay, and then we run it. So it never touched the 1, so we cannot compute it. Okay, let's move on. It's not a big deal. Okay, in order to see the result of the sinusoid wave, I need to make this thing a subplot and compare it together. Maybe subplot is not good here, and we can do another technique. Okay, for example, we want to see a cosinusoid. Y is equal to cosinus of same thing here, but with the different frequency. We need the frequency to be multiply again, and for example, let's compare it this way so we can have a better analysis. And we're gonna use hold on, okay, in order to compare it together, and I need this to be plotted. Plot y. Let's see. Okay, we expect a shift in the time zone in the plot. Okay, you see they have pi over 2, or half of pi phase shift. compared to the sinusoidal one. Okay, we can move on. How can we build a square wave? A square wave is one of the important waves that we should be aware of. There are many ways that we can make a square wave, but here I'm going to show you a pretty quick way, and also it is uh, professional, and they use it in laboratories like electronics or logical circuits or something like that. Let's see what happens. If we use a for loop, okay, for I from okay, for loop, I'm gonna explain it in another video, but let's see it here because it's DSP tutorial, not MATLAB. For is from I goes from 1 to length of our sinusoid. This is something that we explained before. Okay, and if our sinusoid value if our sinusoid value is greater or equal than 0, we need our square wave SQ value to be 1, else we need our SQ value to be 0. I'm gonna make another video for if and for in order to make clear. Okay, and I'm gonna use and it's done. Okay, but here first we need to do a little thing. We should define zeros and put it in the square, so it needs to be one row and how many columns. Okay, try to guess, but this is the answer. And okay, as we put zeros in the square for the initial value, we can clear this one. This else is not needed anymore, but I'm gonna keep it just in order to see the results, and then I'm gonna figure in order to pop up another video sorry, another plot and see the square wave. Okay, and F5. This is our first window. Okay, it doesn't matter now, and the second window is zeros and ones only, and this is the interpolation that made by the plot function of MATLAB. Okay, and this is a step function or a sequence or a square function, a square wave. Okay, this is something really useful. Okay, now guys, let's move to the triangle one. How can we make a triangular window? I'd like you to think about it. There's a function in MATLAB that you can call, let's call it Z, and it's a triangle. How many lengths do we want? Length of x. Length of x, which is our signal. I'm gonna plot it. It's gonna be plotted on the previous window. I'm gonna use hold off here, so hold off. so we don't get confused. Okay, plot Z. Oh my god. Okay, good thing happened. It didn't run because I don't want to see this here. Triangle, sorry, IA. My mistake. Okay, this is our triangle window, but we need this to be repeated every time, just like this. Okay. How can we make a triangular wave? Just think about it and try to write your answer down in the comments area, and maybe I will learn something more. I'm not going to discuss about this one here because there's a for loop that always you can use. Other stuff is possible here also. I from 1 to length of the our signal. Sure, we want to how to put this one delicately. We can have we have to put it in the Q. Okay, and Q is from maybe it's a little bit harder than I thought, but okay, no problem. I'm gonna show it here. Okay, Q is a simple sequence. It goes from 0 to 1, and it goes back from 1 to 0. Okay, we need to adjust a little bit of stuff here. So we need T in order to go to 1. Okay, and then we need this T to go back from 1 to 0, so minus T. Okay, and also we don't want to have two ones in our triangle. We're gonna subtract it minus T, so we get some smooth thing. Okay, plot Q. Okay, you see, but it's really long, so it's doesn't matter. You can always change it, and also change the time axis. You can lower the frequency sample. T should be something like I don't know, 1 over 100. Okay, it makes sense because this is frequency that we are talking about, and I need this one to be concatenated with itself. So Q is Q concatenated by itself. Okay, this is something that makes sense, and maybe we can have I don't know, bigger Q, which is equal to 0, and then this Q is Q concatenated with Q, and then it will be okay. It makes sense now. And how many periods do we want this to repeat? I think 5 is good because we want to count it at the end. I'm gonna put it in another window. Plot is good and stem is good too, so we are going with plot. Okay, let's see only this part. Maybe it's better to just run this part. Press F9 to run only that part. Okay, this is our triangular window, which is a wave. Okay, someone call it Tooth Wave, so maybe Uh, Sawtooth Wave is better for this one. We also have a Sawtooth Wave function here in MATLAB. We can find it just same as this one. I'm gonna put this W, and then how many samples do we want? I don't know, length x, same as our sinusoidal wave. So plot W, and we want to select these things and run it with F9. Okay, F9 it is, and no, what happened here? W, oh, it will give us a single value. No problem. 1 to the length of x. Okay, it makes sense now. Okay, it's really high frequency, so it's not obvious. Let's make it no, it's not the same frequency. Let's put F9. So you see, it's like that. It has peaks down and up, and it's another way to make a Sawtooth wave. Okay, I think it is good for now. And if you had any question or any kind of solutions or different than mine, I'm sure it's correct. Don't give up on your solutions. Try to make them work, and by debugging your errors, you will learn something. Always, always. If you don't make mistake, you will learn nothing. Okay. Have a good day, and please, please subscribe my channel here over here. Yeah. Bye bye, guys.